OK. So those are the two types of TCP attacks that we've seen. You're injecting data or a reset packet into an existing connection, or you're creating a brand new connection pretending to be someone else. And all of these attacks come back to the same fundamental problem, which is that TCP has no cryptography built in. Its goal isn't to give you cryptography. Its only goal was to give you reliability and a better abstraction. But cryptography was just not one of its goals. So at no point did we build in encryption or MACs. And so all of these attacks are possible on plain TCP. Now, to fix this, we won't change TCP, because reliability was its main goal, but we'll instead build higher layers that finally introduce cryptography to stop these kinds of attacks. So TCP by itself doesn't stop these attacks, and we'll rely on TLS to help us stop the attacks later. And that's a higher layer protocol. That being said, there is one very important thing you have to do when you're implementing TCP to at least stop the off-path attacker. And that is choose random sequence numbers. Remember earlier we said that the server and client pick random sequence numbers to start at? Why did we do that? Well, now you know. Because we saw that the off-path attacker has to guess the sequence number if we always start counting at 0, or we use the current time as the starting sequence number, or we always start at some constant, then an off-path attacker could guess what sequence number is coming up next, and that would make TCP totally insecure against an off-path attacker. So one low-effort thing you can do to make TCP secure against off-path attackers is to choose random sequence numbers for every connection so that the guessing of the sequence number is actually hard for the off-path attacker. Don't choose 0 every single time. An off-path attacker could guess the sequence numbers, and then you would be insecure even against the weakest off-path attacker.